11.6 is where we're at starting out today. And 11.6 deals with logarithms, and it also deals with natural logs. And within that, we are going to use your calculator to solve these, because we're going to get some decimal answers that are going to come out of what we have. And if you look at a logarithm has a base 10 as its base, basically. So so every time you see a logarithm, they're going to be in the form of log x equals n, for instance. And if you have that type of a situation, if there is no little number here, remember we talked about those little numbers before, and that was our base that was here, raised to the exponent of n was equal to x. And if there's no base in here, then your base is considered to be the number 10. Okay, so 10 is sitting there, even though it's not written out as a 10, but it is there. Okay, so you do have a 10 in that spot. And so if you reverse this one, it would be 10 to the nth power is equal to x. And that's how we ended up reversing those. And again, logs are reverses, and so you have that kind of pattern going on with them. So again, remember, if there's no number here, there is a 10 there. And so then you can get that reverse of what happens to take place with it. So if I had 10 to the third power is equal to 1,000, and I want to put this into a log format, what I would end up with is log 10, because that's my base, 1,000 is equal to 3. But in our section today, it's just simply log 1,000 equals 3. Now, with these, if we wanted to solve them, of course, we can end up taking 10 to the third power, getting 1,000, or we can take the log of 1,000, and we'll talk about that in a second here. If I had 10 to the negative second is equal to 100th, and I want to write that into log format, it's log 0.01 is equal to, a negative 2. And so that ends up becoming our pattern with that one. And so you have this kind of combinations. Notice I did not put the 10 here, because again, it's there, but we don't end up writing in there. So then if I had 10 to the x is equal to 5.1, what that would look like as a log would be log 5.1 is equal to x. So then, once I get to this format, I don't have a clue as what, of course, x ended up equaling, but if I grab my calculator, I can end up calculating out what x would end up equaling, because on my calculator, get it where you can see something here. Oh, it looks like a pretty good spot. What I would do on that, oops, if I move it up, I'm going to lose it. Is I would go to my log key. My log key is right here next to the 7. Oh, if I get up far enough. It's next to the 7 is where your log is at. And so if I wanted to know my answer in here, I would simply hit my log key. Now it's going to put on there log, and it's going to put a parenthesis. Within that parenthesis, I would put 5.1. Close it in a parenthesis. Be very make sure you do that, because if you don't, sometimes you do something else that you want to do mathematically with this, and if you don't close it in a parenthesis, it takes everything that you put on there and takes the log of whatever it is. So make sure you put a parenthesis in there, hit enter, and you end up with that for your answer. And I think within Hawks it'll tell you to round to I think it's 4 decimal places. So if we rounded this off to 4 decimal places, my answer to this would be 0.7076, because it would round the 5, the 7 after the 5 would make the 5 become a 6, and I'd end up with my answer to that. Okay, so basically it's just kind of plugging stuff in and seeing what you get. Now the ones that you end up solving look like so. They are just plain log 175, for instance, and that's what you would see if you were given this. And so then I'd grab my calculator and once again hit my log button, type in 175, close a parenthesis, hit enter, and my answer comes out to be 2.2430. Now you're going to need that 0 when you put that into Hawks as well, because that is your rounding position. So don't drop it, because I don't know if they'll mark it wrong on you or not, and it might, so be real careful with that part. So then what do you guys get for this one? Log of 6,000 or 66,000. So what's my answer to that one? Log of 66,000. So what would I have? One more time.
4.8195.
Okay. Yeah. So that would be my solution. Everybody got that okay? Because again, it's just plugging it in and coming up with what your answer would be. If they give you a decimal and give you something like 0056, what would be my log of that?
Negative. Hello?
What was it?
Negative 2.25.
20?
18.
18. Okay. Yeah, so that would end up being my solution to this one. Okay? And again, all you simply did was put log in your calculator, comes up with a parenthesis, put in your number, close it with a parenthesis, hit enter, and you have your answer. So pretty straightforward, pretty easy stuff with those. So there's not a whole lot of stuff that you do have to do with that. Okay. So that's kind of the main thing with those is, again, it's just basically entering them in and seeing what you come up with. What about this one? If you have log of a negative 294, what happens? So if you put that one in there, what do we end up with? And if I hit my enter, I get a non-real answer. Okay, that's not an error, meaning that you put something in your calculator wrong. It is just the fact that with logs, you can never take a log of a negative number. They have to always be a positive number when you're doing those. So if you get a negative number, there is basically no solution, or it's non-real. Non-real meaning that if you were to do anything with it, remember we had all those imaginary numbers way back. If you had that kind of thing going on, that's kind of what happens, is you don't get something that's a real number in there, and so you have to be careful with that one. So then if we have log x equals n, remember I told you that that was 10 to the nth power is equal to x. And so I can end up coming up with what my values would be. So these are going to look like log x is equal to 17, for instance. So if I had log x is equal to 17, what would be my answer? Well, I can't just go to my handy-dandy calculator and type in log and put in an x. It's just going to sit there and not do anything, right? And so how I can do this one is to do the reverse or the inverse of a log. And an inverse of a log means that there's that fancy little 10 that's sitting here. So actually it's 10 to the 17th power is equal to x. Now if I put that in my calculator, I'm going to end up with a scientific number, because I can't of course fit 17 zeros after that because of what it happens to have happened to it. So I can't really work that one out. But if I have log x equals 3, then I can take that one and end up coming up with what my solution happens to be. If you look above your log key let's see if I can get it on here. If you look above your log key, notice it has 10 to the x value up there. That is the inverse of a log, and a lot of things on your calculator gives you inverses. This gives you an inverse. Your sine, cosine, and tangent, the keys above those are also the inverse of those. Down here we're going to work with the natural log key, and above it's an inverse. And so you got some inverse things built in there. And so if I want to solve this one, I'm going to go 10 to the third power is equal to x. So I can just go second, hit my log button, which puts a 10 with a caret key, and then type in a 3, and I will get my answer for this problem, and that happens to be 1,000, so I can work it backwards and come up with what it would be. So then if they give you log x is equal to 1.2563. If they say that's what you happen to have for your value. So when you see this, you know that you can go second your log key, put in whatever it's equal to, close in a parenthesis, hit enter, and you come up with an answer of 18.0302. And that becomes what my answer would end up being for that one. Does that make sense? Yes? Are we good? Not good? Okay. And one more. So if you had log x is equal to 14.3, what would be my answer to this thing? So what would come out of it? So then, once again, second log gives me my 10 to raise to a power, and my power is 14.3, and close it in parentheses, and I end up with the answer of 1.9953, and that's times 10 because I got an e down here at the far end of it to the 14th power, and so I don't want to forget that to the 14th power in there. Because if I just write that, it makes it look like that's what it is, but actually this is decimals moved back 14 places in here to end up giving you the answer to that one. Okay, so that's a pretty big number that you happen to have with that one. Are we okay with these? We're going backwards and forwards with them. Now, sometimes they end up giving you something like log x equals y. If you have this situation, there isn't much I can solve with it. So the only answer that I can give is 10 to the y is equal to x. And we'll run across some of these that you really can't do a whole lot else with them because they don't end up solving. And another one might be, of course, if they give you log 9 equals x, that means it's 10 to the x power is equal to 9. And that one you could come up with a log of it for it, but sometimes I just leave it as is. And again, when they do that, I'm not exactly, you'll have to pay attention to what comes up in your homework part for those. But that's our logs and our inverses of our logs. And so we've got both of that piece together. Now we're going to move on to what's called natural logs. And they're just as easy as these last ones because with a natural log is your ln, and its inverse is e to the x power, because you're taking it and reversing what you happen to have in there. So natural logs they look like ln x equals 4, and if you reverse it and turn it back, in natural logs, like in regular logs, there is an e right here. So they're signified with an e, and so you have to be careful and make sure that you remember there's an e there. So if I reverse this one is really e to the 4th power is equal to x. And so I can end up coming up with what my solution would be for that if I know what my e happens to be. Now, there is a number associated with natural logs. When I was taking my math classes quite a while back, you had to remember what that number was. And you guys don't have to remember what the number is because it's built into your calculator. And if you go to your ln key, your natural log key, and that natural log key is across from your 4, up above it is e to the x power. So if I simply go second, e to the x power, put in a 1, because if I raise e to the first power, it's going to be what e happens to equal. And so now if I hit enter, the e that I had to always remember, that you guys don't have to remember, which is one of them wonderful things, happens to be that number right there. We didn't have to remember that many decimal places out, but I think it was like 4 or 5 decimal places. So every time we ended up with a natural log, we had to figure out what that value would be in there to come up with that. So, so that comes out to be what you would have for that value. So if you look at e itself, e is equivalent to 2.718281828. And so that's what it happens to equal. So if you're doing reverses of natural logs, that's what you have to pay attention to, and that's the fact of what that inverse happens to be. So to solve natural logs, so if I have the natural log of 4, what's it going to equal? So it's just as easy to calculate that out by just simply going to your natural log button, putting in a 4, closing it in a parenthesis like we've talked about before, hit enter, and my answer comes out to be 1.3863. Because when I do that part, again, I round it off to 4 decimal places, and that's what I get for my answer. So pretty straightforward stuff, right? Okay. That's, what was that?
Do you think that the E4 and E4 power equals X? So you just put in second P and then EX and then the fourth power?
Oh, for what one? This one? Oh, no. This one, if you're going to solve this one, we're going to do some of those in a little bit, but if you're going to solve that one, you just simply go second, hit your natural log key or your ln key, put in a 4, close it in a parenthesis, hit enter, and there's your answer.
Right, that's what I heard.
Yep. So I guess I should put that up here. So my answer to this one is 54.98 or 598 right there. 598.2 would be my answer. Okay. Yeah. So it's just kind of the same thing of working those guys backwards and forwards. How about this one? How about ln natural log of 3.5? What will I get? Natural log of 3.5. What comes out? 1.2528. Okay. Great. So probably the easiest section we've had all semester, right? There haven't been a whole lot of easy ones, but this one tends to be not so bad. How about the natural log of 0.01? What will that one equal? 2? 2? Okay. Yep. So negative 4.6052. And so we're getting up with that answer as well. So then, inverses of natural logs end up being, if we have ln x equals y, again, there's that little e there, so e to the y is equal to x, and so we can reverse it and come up with what our reverse happens to be. Once again, there's that little e that's not written in there, but it sits there as our reverse for a natural log, and so you reverse them. So what do we get for an answer to this one? ln, or natural log of x, is equal to 2. What will that equal? So I have to reverse it. So it's e to the second is equal to x. So what is e to the second? So second, natural log, type in a 2, close it in a parenthesis, hit enter, and my answer comes out to be 7.3891. Okay, everybody got that all right? Okay, so you reverse them and just see what happens to them. How about ln, natural log of x, is equal to 40. What happens to that one? What was it again?
2.3539.
Okay. Well, what's the e mean? Times 10 to the 17th. Okay. Yeah, so you got to turn it back into scientific notation for that one. So you want to watch those and make sure you get them flipped around, turned around, and back into what they need to be for those. Okay. That good so far, do you think? Okay. Now, the others that we can run across is 10 to the y is equal to 33.4. Now, I don't know what y is. Y could be all kinds of things. But if I know that this is the opposite of a log, I can go and reverse it back into a log. So remember, logs are the base of 10 goes here, the answer goes here, is equal to y. So when I do that, of course, I don't need my 10 in there. So on my calculator, when I reverse this thing, all I simply end up with for my answer is I could calculate that back out and come up with what y happened to equal for those. I'm thinking that all you're asked to do in Hawks is just to leave it like this, not solving for y. But we could, because we could put log 33.4 into our calculator and come up with what y happens to equal for that. But I don't think they end up coming up with what your answer would end up being for those. I think they leave it as it is, because what I've written in my notes here is that it was left as is. So let's do another one. 10 to the y is equal to 4.1. What's that one going to end up equaling? So it's going to be log, so I got to turn it back. And what will it be? 4.1 is equal to y. Yep. Yep. So that's what y would end up equaling. Then these are just examples. A natural log of x is equal to a negative 8. What's that one going to come out to be? We just got done doing some of those because we ended up reversing them back. And so what would my answer be? E, yep, to the negative 8 is equal to, what's it equal to? So now I got to put it on my calculator, because that one I got to come up with an answer for. It's equal to x in this case, but what is it going to equal? 3.3546? Okay. All right. Times, oh, I'm not done yet. Oh, okay. Times 10 to the negative fourth. Okay, right. And so because it's to the negative fourth, I could move this decimal point back 4 places. And my answer would just simply be that, because if I move it 4, 1, 2, 3, 4 back, I would end up getting that for a value that would be in there for that one. How about ln to the negative 38.74? What's that one going to end up equaling? Put that on your calculator and you get an error. Yeah. So this is one of those undefined. So like logs, you cannot take a natural log. A natural log of a negative number. So that does kind of pop up there once in a while. So you do run across those when you're working with them. How about this one? E to the 7th is equal to y. So whenever I see an E, what do I know? It's going to become I reverse this. I got the inverse of this whole thing, and I don't think we quite did one of those either. The inverse, of course, is a natural log. The E is the base. The answer is y, and the 7 is what the natural log would be equal to. And so if I reverse it in this format, it's just lny is equal to 7. The E is there, but it's not written out in my final answer. So I leave my E out of there. And that one I can't solve. Can't do anything with it. I could solve it here and come up with what e to the 7th power happens to be and what y would be. But I think it tells you when you get into Hawks that it wants this put back into a natural log. It will state that in the instruction part. And so if it states to put it back into a natural log, then you do not want to solve it. You don't want to take e on your calculator, raise it to the 7th power, and come up with an answer, because it will tell you to leave it in the natural log form. And so you got to pay attention to those things and read your stuff with that. So, and then I think the logs they do the same thing with, because 10 to the y is equal to 9.5 is another one. And in Hawks, the instructions will say turn it back into a log. So what would my log be if I turn that back into making it a logarithm instead? So log. And again, it's that reverse. We did the reverse, I don't know what section. It was one of the previous sections. 10 is my base. The answer comes here, and y sits out to the other side. But when I type it into Hawks, I only want log 9.5. I don't need the 10 there, because the 10 is signified as being there when I work that one through. So it will state that to you of what you do end up needing to do with that. So, how about this one? Log x equals a -3. What would be my answer? What was it again?
10 to the -3rd.
Yeah, 10 to the -3rd. And what's 10 to the -3rd? Work it out on your calculator. Yep, you are right. Yeah, that's what it would end up equaling. Okay, we all right with these? Need to do more? Now, they do kind of hop around a little bit, so I would probably go into practice for a little bit and get used to what you're doing with those, because they ask you some different things in there, and practice it some, because again, they kind of jumble them all together. You may want to do this one from lowest to highest when you go up and set your values when you do practice, so that you get some of the more simple ones as opposed to hopping in and getting some of them that are all mixed up. They have a tendency to do them in order when they end up doing that one. So yeah, that's all of 11.6. Pretty straightforward. All right, 11.7. Last section, yay! We finally made it to that part. And this one is solving exponential equations with same basis. So we got some stuff with some same bases in there. If you go into the instruct in Hawks, the instruct talks about all of the power rules power rules, meaning x to the 5th power times x to the 3rd power is equal to x to the 8th power, where we added our exponents together. Another one is b to the negative 1st becomes 1 over b to the 1st power, because a negative means it's in the denominator. We use this one and reverse it in here to take it back to what the base would happen to be, and you'll get to see some of those as we go through with those. B to the 0 power is of course equal to 1, if we remember that our base with the 0 is in there. If we have b to the x over b to the y, that is b to the x minus y, or b to the 5th over b to the 3rd is really b to the 2nd, because I subtract my exponents when I deal with that one. B to the 3rd raised to the 4th, distribution, 4 times 3 gives me b to the 12th, and we use this one also in this section because we get some things that we need to find common bases to, and then do that multiplication in order to get a solid exponent at the top that we're dealing with. Another one might be 3 to the x raised to the 3rd. That's going to mean 3 to the 3rd power, x to the 3rd power. And since I can multiply 3 to the 3rd power out, 3 to the 3rd power, what's it equal to? 27, yep, x to the 3rd. And so that's what comes out of that one. And so we got that power going on in there. So those are my basic properties of exponents, and we've been dealing with these. We use them in chapter 9, I think it was, where we had to combine some of our radical values and turn them into exponents and added fractional exponents and that type of stuff. So we've dealt with them in here. So it's kind of a review that comes into play. In this section, though, and I'm going to turn the page or that page and start a new one. There are properties that go along with of equations with exponents or logarithms. And those properties are, the first one we've had before, and that one is if b to the x is equal to b to the y power. What did we learn about that one the other day? Remember that one? It's been a little bit. If my bases are the same, we can say that our exponents are equal to each other. So x will equal y. So if the bases are the same, the exponents are equal to each other. So an example. An example of that one might be, find one that I've got saying things. 3 to the x plus 2 is equal to 3 to the 4th power. So if my bases are the same, then I can end up finding out what x is equal to by taking the two exponents and setting them equal to each other. And if I set them equal to each other, I then end up finding that x is equal to 2, and that's going to end up making these two end up equaling out. So what I've done is taken this and I've solved and found out what x happens to be to make that work. And so, nope, this one right here, I'm going to put 3 or 2 back in here. So 2 plus 2 is actually 3 to the 4th power. Okay? So all you're basically doing is saying what would x equal to make this a true statement. Okay? Now, if you have something like 9x is equal to 3 to the 2 x, or 3x plus 1, if you have this, for example, I don't have like bases, do I? This base is not the same as this base, but I can make them be the same, can I? because 9 here is really 3 to the second power times x, or 3 to the 2x is equal to 3 to the 3x plus 1. And then, because if my bases are the same, I can set my two exponents equal to each other. Oops. Get my 2x over and subtract a 1. Gives me a negative 1 is equal to 3x minus 2x, or x. So then therefore I find out that in this case what makes these guys true is that x is really equal to a negative 1. So if I put a negative 1 back in here, does it equal? So if I do a check, does it work? So I have 9 to the negative first power is equal to 3 to the 3 to the negative 1 plus 1. Is that a true statement? 9 to the negative first power, that gives me 1 over 9, because it's putting it into the denominator, because that's what a negative exponent tells me. The other side, 3 times negative 1, is a negative 3 plus 1, or 3 to the negative second. But when that gets reversed and moves to the bottom, it becomes 3 to the second power, or it also becomes 1/9. So I know I did my math correctly. So if I plug 1 back in from my original problem up here, I can prove that that negative 1 is the correct solution. So I can plug it in and see what happens. So that again is if my bases match each other. So if the bases are the same, then I can end up doing that type of stuff with it. So that's property 1. Whoops, yep. And what I'm looking for when I see this one is that I have common bases, and that the bases are going to be identical to each other if I can force them to be identical. And sometimes you need to maneuver a few things in there. Another one that's like that is if you have 5 to the 2x power is equal to 1 over 25. If that were my answer that I was given, I can end up breaking 25 apart. So 5 to the second power is equal 1 over 5 squared. We good so far? 25 is 5 times 5? Yes? Okay. And so if I bring it back up to the top, because it's basically saying it's a negative power of what I have, then my bases match. So now I have 2x is equal to a negative 2. Divide by negative 2, and I find out, whoops, divide by positive 2, get my 2's going right here. I find out that x is equal to a negative 1. And so, does it stand to be true? 2 times a negative 1 is a negative 2, which makes the 5 go to the denominator and become positive, and 5 squared becomes, of course, 25. And so I figured out what my x happens to be with that one. And so that's basically going through and taking a look at what's involved in that very first process that I happen to have. Number 2, the property for number 2, we don't end up doing a whole lot with, because it's saying that if x is equal to y, then b to the x is equal to b to the y power. So basically it's a reverse. This reverses the first property. So it reverses the first property. So it's just kind of the opposite of what takes place with that. The third property, and again I need more room for that one. The third property is that if you have log bx is equal to log by, meaning that I have two logs that are involved in my equation, then x is equal to y. Meaning that I have both of those situations, then I can have that happen. There is some things that you have to be aware of, and that happens to be that x needs to be greater than 0, and y needs to be greater than 0. And again, the reason for that is that we can't have a log be with a negative. Remember, we've got negative values that come out in here. So if I get a negative value happening in this part, then I can't have that because I get a log which is negative, and we found out those do not work with that situation. So they have to be greater than 0 whenever we work with that one. So one of those might look like, so we get some examples in here of, let me find one. It kind of throws some stuff together. I don't want that one just yet. Log 6 of x plus 2 is equal to log 6 of 4. So if I have something like this, where I have an equal sign that's in between, this piece, x plus 2, is going to be equal to 4. And so then all I need to do is solve that side, and I get x is equal to 4 minus 2 is 2. So I find out that x is equal to 2. And so if you plug 2 back in, what happens? 2 plus 2 is, of course, 4. And then both are matching on either side with those. And so it comes out being what you have with that. How about this one? Log 10 is equal to log 3x. Log 10 is equal to log 3x. What happens then? Well, once again, 10 is equal to 3x. And so divide by 3, and I find out that x is equal to 10/3. And again, if I plug that in there, of course, it's going to come out to be what it should be within that one. So if you got logs on each side, then that's the piece that ends up working for those and coming up with what your answer would end up being. So that is the third property. And finally, the fourth property is again the reverse of this thing. And so the fourth property is if x is equal to y, then log bx is equal to log by. And so again, same stipulation, x needs to be greater than 0 and y needs to be greater than 0 in order to make this thing work. And where we use that one is if we have something like so, where we have 6 to the x power is equal to 18. If you have 6 to the x power equals 18, can I do that one? Can I ever get 18 to look like a 6? Okay, so you use it when you cannot find like bases. So if I can't find a like base, then I can use this property to help me out with this. So I can put a log in front of each of these. This one, in order to solve it, if I go back to our previous section where we did that, when we raised something to a power, remember we put it in front? And when I stick it in front, then I end up with x in log 6. To get x by itself, divide by log 6. And when I do that, these of course cancel and gives me x is equal to log 18 over log 6. Now, what does that equal? Well, go back to your handy dandy trusty calculator, and we are going to calculate out what that would equal. So basically, I need to do log 18 parenthesis divided by log 6, and end up with an answer of 1.6131. And so that becomes my answer to it. So I can end up solving these if my bases do not match by putting logs in there and coming up with what their values happen to be. All right, that's the basis of all of these, of what our properties happen to be. Let me see if we can do another one that's like that one and come up with what our values would end up being. How about this one? This is going to be similar. So I kind of wanted to keep these together so you get an idea of what to do with each of your properties. 3 to the x is equal to 36. If I have this one, I can never get 36 into solid 3's, so I don't have like bases with this. So once again, put a log in front of each. Bring my x out in front of my log. Divide by log 3. And we will simply find out that x is going to be equal to, what does it equal if you put that one onto your calculator? 3.26. 19. I agree. Okay. And again, you're rounding it off, so you're just taking the top thing, dividing it by the bottom, and coming up with what your solution happens to be. And so that ends up being what you have for that. Okay. So anyway, that's the gist of those. Now, each of these end up adding in, of course, extra stuff that makes them have more pieces to them as you work through them. They end up adding natural logs in here as well. And when you have natural logs, of course, you have to work with the e portion of those if you're going to end up coming up with what your values are. So if we had e to the 0.2x is equal to 50, for example, e is, of course, a natural log. When I reverse this, what ends up happening? So if I reverse this, this is kind of back to that previous section we had, because if I reverse it, I have the natural log of e, and then I'm going to have 50 in here is equal to 0.2x. The e is gone, of course, and so my reverse of that is going to end up giving me divide everybody by 0.2. That's the thing that makes this one a little different than the last section, because we didn't have to divide by 0.2 to get our x all alone. Our x just happened to be alone. And so then what comes out of this one if we get an answer to it? What would I have? So natural log of 50. What was it?
Well, I got 19.56.
Okay. Yeah. So that's what we'd end up coming up with, all right, for our answer to that one. So you've got some combination stuff of what ends up taking place with those. Then they start getting into taking powers and ending up giving you opposite bases in here. Let's go through this one. 5 to the 2x plus 1 is equal to 10 to the 7th power. So if I work this one through, bases don't match, right? And since they do not match, I need to put a log in front of each of those. So when I do that, what do I have? Well, that's got to come down in front. And so I get to that point, but in order to, oops, this is an x, not a 7. Yeah, x in there. Help if I get my pieces correct in there with what I happen to have. But if I have log 10, remember there's that little 10 there, in last assignments we talked about having these things match. So what that is really equal to is x times 1. Now are you guys going to know that? I don't know if that's something that you would be able to pick up with that or not, but that is what ends up taking place with it. So to get this all by itself, I can't just divide off log 5 because it's times this whole thing, and I've got x's on both sides of this equation, and this is probably one of the harder ones that shows up in your homework. I need to distribute it. So log 2, or 2x times log 5 is 2x log 5. 1 times log 5 is plus log 5. Subtract the 2x log 5 from both sides. Leaving me log 5 over here is equal to x times 1 minus 2x times log 5. We okay so far? Let's get my x's all on one side and get my numbers on the opposite side. Factor out an x out of this other side. We all right? Yes or no? All I did was pull an x out of this other side when I got my x's all together. Then divide by 1 minus 2 log 5. And so from that I find out that x is going to equal, and now I need to use my calculator and take log 5 all over 1 minus 2 log 5. And what does that come out to be? So when I stick this thing on my calculator, get it all to show up here, I'm going to go, let's clear everything out so I got a clear screen. I'm going to log 5 divided by parenthesis 1, because I want to put a parenthesis in there because I want it to do all this. I don't want log 5 divided by 1 and then subtract log 2 5. So I want to make sure I do that. 2 times log 5 parenthesis, and close it in another parenthesis. Is that showing up? There. I'll move it up a little bit. And now when I hit enter, I will end up with an answer for this whole thing, and so that will end up being what comes out of this. So I end up with a negative 1.7565 would be my answer to it. So again, that's one of the longest ones that you'll have to happen to run across. And again, it was because my bases didn't match. If this would have been a 5, then all I would have did is set 2x plus 1 equal to x, and I would have solved it. But because the bases were different, 5 and 10, that's when I need to go through my whole process here. So let's kind of do a recap with this one because it is a long one. I first set them into logs because I can't solve it without having a log involved. And then from that, I end up multiplying because I need to get all my x's on one side. If you did log 10 over here, you would end up finding out that it was of course equal to 1 when you work that piece out. Distributed, 2x times log 5, 1 times log 5. Got my x's together. Then I factored out an x and divided by it to get x by itself, and then came down and ended up with my equation down here, or my piece that I had to put on my calculator. And again, don't forget in the bottom to put parentheses around this, because it will, by order of operations in your calculator, it will only divide log 5 by 1, and then it will subtract that from it. So if you put it inside parentheses, it'll do the math and then divide it into log 5 for that one. So again, that's kind of one of the longer variety of problems that you can run across in your homework sections with those. Then if they put logs on both sides, so this one would be the case of log x minus 1 plus log x minus 4 is equal to 1. So when we have this one, we got to reverse this like we did in the last, in 11.5, I think it was, where we did our addition, and we knew that this was log x minus 1 times x minus 4 is equal to 1. If I take this and do the inverse of it, there's a 10 right here, so 10 to the first power is equal to x minus 1 times x minus 4. And now basically all I have left, once I've gotten that log piece out of there, is I have a multiplication happening here. The reason I had to reverse this is because this side, of course, didn't have a log on it, so I can't use my property, but I can use the inverse of this. And so if I FOIL this side, so FOIL it, x times x is x squared. X times a negative 4 is a negative 4x. Negative 1 times x is a negative x. Negative 1 times a negative 4 is a plus 4. Move my 10 over. Combine like terms. And so 4x and a negative x is a negative 5x. 4 and a negative 10 is a negative 6. And then look at that and see if it can be factored. Can I factor it? Let's see. It's a simple factoring. I don't have to do that long, drawn-out stuff. Factors of a negative 6 give me a negative 5. Well, if this is negative, one's negative and one's positive. So it's going to be a negative 6 and a positive 1. Set both equal to 0. And add 6. And I find x is equal to 6. Subtract 1. Find x is equal to a negative 1. But because I'm dealing with a log when I started my whole process, I cannot use the negative in there because it's going to create problems for me with my log. This one would come out to be a negative value right here, and so would this. And so therefore I can't use a negative 1. But the positive 6 will make it work correctly, so I need to kick that piece out for that problem. Again, recap of this one. It's logs that are in it. No log on the second side, so that means I have to reverse it, or take the inverse of the log. So inverse of the log is what I need to do with this one. The base is 10 on my log once I put the two back together, so I get 10 to the first power is equal to what that happened to be. FOIL, factor, kick out negatives, and I get my answer to that problem. Let's take a look at another one that's like that. Let's see if I can find another one in this stuff that has a maybe all the other ones have logs on the opposite side. This might be the only one that didn't have a. Yeah, looks like everything else does that I've ran across in my sections to work on. So maybe you won't even run across any of these when you do your Hawk stuff. I know it didn't pop up in any of my exercises. Another type, not quite like the section where we had 11 different possibilities of stuff that could possibly come out of those, but another one is when you have logs on both sides. So you have log x minus log x minus 1 is equal to log 3. Now these are easier because you have logs in both parts. This is kind of out of focus.
Are those supposed to be exponents?
There, that's better. Pardon?
Are those supposed to be exponents?
Yep. We got to put it back together though first, because this piece is really log x over x minus 1 is equal to log 3. Because that again is reversing what we did in one of the previous sections. Now because both have logs, these are easier because my rule said that if I have two logs, then the values next to the logs are equal to each other. So x over x minus 1 is equal to 3. So to solve it, I need to get rid of x minus 1, so I'm going to multiply both sides by x minus 1. So that gives me x is equal to 3x minus 3. Subtract 3x. Gives me a negative 2x is equal to a negative 3. Divide by a negative 2, and we find x is equal to 3/2. So that would be my solution. Can I have 3/2? Yeah, because it's positive. It's not going to create a problem for me. It's larger than 0, and so I'm safe with that one. So again, this one's different because it's got logs on both sides to work with. Same thing happens if you have natural logs on all sides. So if you have ln times x minus 1 times x minus 7 minus the natural log of x minus 1 is equal to the natural log of 2. Those are on all sides here. So if I put this back together, I have ln is x minus 1 over x minus 7 all over x minus 1 is equal to ln, or the natural log of 2. What cancels? So if you look at this side, I can end up canceling my x minus 1. So really I have natural log of x minus 7 is equal to the natural log of 2. So x minus 7 is equal to 2. Add 7, and I find x is equal to 9. And again, I can have 9 because 9 is going to make it come out to be true with what I happen to have. If you check these and you plug it back in, 9 minus 1 is 8. 9 minus 7 is 2. 9 minus 1 is 8. And so when you check it on your calculator, you are going to go back through, and 8 times 2 is 16. So you have ln 16 minus ln 8 is equal to ln 2. So if I reverse it, natural log of 16 over 8, and 16 divided by 8, of course, is 2. So we know we did it correct. And so I get the natural log of 2 on each side. Or if you want to check it with your calculator right here and put natural log of 16 minus the natural log of 8, get that answer, then get the natural log of 2, and you can check it that way too. Get your numbers to come in there. Okay? Okay, a couple more, or a few more actually. One more with a natural log in it, and so let's do this one. Natural log of 5x plus 7 times x minus 8 minus the natural log of x of 5x minus 7 is equal to the natural log of 1. Let me move it up here. It's kind of fuzzing out there at the bottom. So reverse the subtraction. That should be minus in there, and I have plus. Minus 7 is equal to the natural log of 1. Cancel anything that cancels, so this piece cancels in there. So that leaves me with the natural log of x minus 8 is equal to the natural log of 1. So, because they're both natural logs, I can say that their values that are connected with them are equal to each other. So add 8, and I find x is equal to 9, and I'm all done. So 9 would end up being my solution to that one for my value. What happens, let's see if I got one more of that variety. Flip my page over here. Go back the opposite way. How about this one? Natural log of x squared minus 4x minus 45 minus the natural log of x plus 5 is equal to the natural log of 8. Now they kind of give you a little bit extra work in this one because they don't factor it for you. You need to factor this piece. So that piece, if I factor it, what's it going to factor to? X minus 5, or x plus 5, and x minus 9. And always what they give you right here is usually one of their factors over here, so be aware of that. So then if I reverse it, and the x plus 5's cancel. And then I find out that x minus 9 is equal to 8. Add 9. And I find out that x is really equal to 17 when I'm all done with it. So again, it's that combination of plugging some stuff together and coming back with those. Okay. How about this one? 7 to the x power raised to the 4th is equal to the square root of 7. No logs in here. Can I make my bases match? What do you guys think? So I've got 7s. That looks like it might be hopeful. And this one, all I gotta do is multiply and distribute that 4 times the x and get 7 to the 4x power. But what do I know about this thing? What was that radical? Radical was equal to what? If I turned it back into an exponent. What's the square root as an exponent? Square root as an exponent will be 1/2, yeah. So really it's 7 to the 1/2 power. And so I've got like bases now. Notice 7 and 7. So my first law says that if they got like bases, the exponents are equal to each other. So gotta solve for x, so that means I'm going to multiply this side by 1/4, multiply that side by 1/4, so these cancel. So 1/2 times 1/4 ends up being 1/8 if I get it on the screen. So you get 1/8 out of that. So you can reverse it and come back with an answer that you would have for that. 4 times x to the x squared minus 1 power is equal to 4 to the 3rd power. What's going to happen with this thing? So if I work it out, 4s are bases, so they match each other. So again, looking for like bases. Take my exponents, set them equal to each other, and if I add 1 to both sides, I get x squared is equal to 3 plus 1, which is 4. Yep. Good old chapter 9. Chapter 9 seems to want to be in every chapter that we've been doing since it. So I get x is equal to a plus or minus 2, or x could be a negative 2 or a positive 2. So that would be what I would enter in there. So I could have that kind of combination with those to come up with that. About this one. 9 to the 4x plus 1 is equal to 3 to the negative 3x minus or plus 3. Do I have like bases? Yes or no? I can make them have like bases, can I? Because this 9 is really 3 squared. Distribute the 2 by everything that's in there. 2 times 4 is 8x. 2 times 1 is 2. Now I have like bases, so I can take 8x plus 2 and set it equal to 3x plus 3. And what comes out of there? Well, I'm going to minus 3x. I'm going to minus 2. 8x minus 3x is 5x. 2's are gone, 3x's are gone, 3 minus 2 is 1. Divide by 5. Find out that x is equal to 1/5. So my answer is 1/5 with that one. And another example. These again are all things that pop up in your homework part in Hawks. And so what happens with this one? So again, my rules of exponents say I can stick those two together. So -4 and a -7 is a -11. And so, what do I find? Bases are the same. 3's are what matches out. So I have a -11 is equal to x. So that's what it comes out to be. So I get a -x in there for that one. And let me go back another page here. See if I have anything else that is in this part. I think that's it. Are we okay? Do we need to do some more? Because I can find more. I know I can find more. I know there's more other places with that. But that gets you through that piece. So make sure you get that part together.